Hi guys, welcome back to the Seaborn, a statistical data visualization section. Let's deal with the categorical data in this section. Seaborn provides a range of options to plot categorical data. Seaborn on its website in categorical data plotting section divide categorical plots into three groups: swarmplot and stripplot are those that show each observation at each level of the categorical variable. Boxplot and violinplot are those that show the abstract representation of each distribution of the observation. Barplot or pointplot are those that apply a statistical estimation to show a measure of central tendency and confidence interval. Along with the above-mentioned types of categorical plots, we will also discuss widely used categorical plots, such as countplot and factorplots in this section. Let's move on and start with the new Jupyter Notebook. File, Notebook and Python 3. So here we have a new Jupyter Notebook. First thing first, we need to import Seaborn library. So import Seaborn as SNS. Let's set matplotlib inline as well, because we want to see the plots within the Jupyter Notebook. Matplotlib inline. We are going to work with the tips data in this section. Let's load the tips data into tips. So tips equal to SNS dot load underscore data set, and the name is tips. So we are actually using the Seaborn's built-in dataset tips here. So let's load this dataset. It's always good idea to check how the data looks like. Let's check the head. Tips dot head. Sorry, it should not be 0. So here we have total bills, tip, sack, smoker, day, time, and size. Let's add some cells here. So let's move on with the first plot, which is a strip plot here. Strip plots provide a simple way to show the values of some quantitative variables across the level of categorical variable. It draws a scatter plot where one variable is categorical. Let's plot the total bill for each day in the week in our tips data to see how the strip plot looks like. We can call strip plot using SNS dot strip, so always tab for autocomplete. And if we look at the document string, shift tab, let's talk about X, Y, and data at the moment. So our X is day, so we are taking this column day. Our Y is, we want total bills here. Let's copy this thing. And our data is tips. So what we are passing, X, which is day, Y, total bills, and our data, which is tips. Let's run this cell. So here we have our first strip plot. We see that the data points are overlap, like here. We are seeing lots of overlapping. This is common and makes it difficult to observe the full distribution in our data. There is a parameter Jitter which is useful and provides easy way to solve this overlapping issue. Jitter adjusts the position of data points along categorical axis. It is then easier to see the distribution. Here we have day as a categorical axis. We can specify the amount of jitter, or we can just use true for good default. So let's copy this one here, paste it here. Let's press Shift Tab again. And here we have jitter equal to false, which is default value. If we move down, so jitter, this can be useful when you have many points and they overlap, so that it is easier to see the distribution. Let's pass in jitter equal to true here. So we can copy this one here, paste it here, and pass in jitter equal to true. And let's run this cell here. Now we see the data points are not overlapping anymore. If we press Shift Tab, there is another parameter, palette, which is none by default. Palette is colors to use for different levels of the hue variable. So let's pass in palette equal to cool, warm, and we can pass in hue as well, equal to sex. And let's rerun this cell here. So now we have male in blue color, and in light orange color we have females, and the data points are not overlapping. This is optional. If you don't want, you can simply delete it, and if you rerun it, you are getting kind of default palette here. So let's move on to the swarm plot now. Swarm plot is similar to the strip plot and uses different approach to avoid the overlapping issue in the data points. It positions each scatter point on the categorical axis with an algorithm that avoids overlapping points. This somehow gives a better representation of the distribution of our values. Let's call swarm plot here sns dot swarm. So we can press tab for autocomplete, and we can pass in the same variables here, x, total bills. This is our data, and let's copy this one here, paste it here, and pass in hue equal to sex again. Let's rerun this cell here. So here we have our first swarm plot. In this plot, we have categorical variables along the x-axis. However, a very common practice is to put the categorical variable along the vertical axis. This is particularly useful when the category names are relatively long or there are many categories. If we press Shift Tab, we see here orient, which is none by default. We can pass in V for vertical or H for horizontal. But usually plot orientation can be inferred from the data types of the variable passed to X or Y. Let's try plotting days along Y and total bills along X, with hue equal to time here instead of sex. Let's copy this code, paste it here, and we said we are going to take time as hue parameters, and our X is now total bills and our Y is day. Once again, we are changing the axis for total bills to x-axis, and our categorical variable, which is day, we are putting along y-axis. Our data is tips, and we are passing hue as a time. So let's run this cell here. Here we have our swarm plot. So now we have lunch in blue and dinner in green color. We can observe from this plot that almost all the customers come for lunch on Thursday. Not many green dots are in Thursday. And on the other hand, almost all the customers come for dinner on weekends. On Friday, not many people go out for lunch or dinner. On Friday, they may want to save money for Saturdays or Sundays, and maybe they don't have enough energy on that day and they want to save their energy for weekends. This is obvious, and we see this trend most of the cases in our situation as well. On the last working day, we may not want to go out with friends and family, but on Saturdays and Sundays, we usually go out for dinner with our family or friends. However, on most of the working days, we are at work and we go out for lunch, but we don't really go out for dinner most of the time on working days. So let's move on to the distribution of observation within categories now. Let's talk about the box plot here. A box plot, also known as box and whisker plot, shows the distribution of quantitative data in a way that facilitates comparison between variables or across levels of categorical variable. Let's learn with some example now. So let's add few lines here. If you remember, in our matplotlib section, we had a short introduction to the box plot as well. So let's call sns dot boxplot, and let's pass in X as a day, Y as a total bill, and data as tips. So here we have X our day, Y our total bill, and data is tips. Let's run this cell and discuss what is box plot now. The box plot shows the quartiles of the data set, whilst the whiskers extend to show the rest of the distribution, except for the points that are determined to be outliers using a method that is a function of the interquartile range. In statistics, the quartiles of a ranked set of data values are the 3 points that divide the data set into 4 equal groups, like 1, 2, 3, and 4. Each group comprising a quarter of the data. A quartile is a type of quantile. The first quartile, Q1, is defined as the middle number between the smallest number and the median of the data set. The second quartile, Q2, is the median of the data, whereas the third quartile, Q3, is the middle value between the median and the highest value of the data set. Let's try to understand this box plot. We have total bills along Y, and we have categorical data along X, which is our day. If we look at one of the box plot, we see that data points in each box, or box and whisker plot, are divided into 4 quartile groups, like 1, 2, 3, and 4. 1, 2, 3, and 4, and same for all other boxes. Quartile group 1, which is Q1, is between the bottom whisker and the bottom of the box, from bottom whisker to the bottom of the box. Quartile group 2, which is Q2, between the bottom of the box to the line in the box, which is median. So this is our median. Here, this is the median. Group 3, which is Q3, is between the median and the upper end of the box. So from this median to the upper end of the box. And the last group, Q4, is from the upper end of the box and the upper whisker. So we have Q1 here, Q2 here, Q3 here, and Q4 here. Let's introduce hue equal to sax, or maybe hue equal to smoker, to get more information from our data. So we can copy this line, paste it here, and let's say hue equal to sex. And if we run this cell, now we have female and male. Male in blue colors box plot and female in green color box plot. We can set the color according to our choice. We can pass in palette, PA, say equal to rainbow, and rerun this cell. Now we have changed the color according to the given palette. You have range of options here. You can explore more from the Seaborn's documentation on palette. So in this box plot, we split the data into two boxes for each day. Like Thursday, we have two boxes, one for male and one for female. On Friday, once again, two boxes, one for male and one for female. Now, from this box plot, we can compare daily behavior of the person along with other categories such as sex here. This is a true power of Seaborn, which quickly allow us to add another layer using hue parameter and provides in-depth information from our data, which is very quick and very smooth. So let's move on to the next one, which is violinplot. Violinplot draw a combination of boxplot and kernel density estimate. I hope you still remember the kernel density estimate from the previous lecture. A violinplot plays a similar role as a boxplot and whisker plot. Let's plot the data and learn how the violinplot look like. Let's copy this code here, paste it here, and instead of box, we want violin. So our X is day again, our Y is total bill, and our data is tips again. Let's run this cell. So here we have our violinplot for X equal to day and Y equal to total bills. Actually, we have a box plot. This is a box plot on top of a violinplot. So unlikely the box plot, the violinplot allows us to actually plot all the components that corresponds to actual data points. The violinplot is essentially showing the kernel density estimation of the underlying distribution. As compared to the box plot, which is very easy to read, the violinplots are little harder to interpret. They give a lot more information as far as the distribution of all the points themselves is concerned, but on the cost of more time to looking and understanding the violinplot. Before presenting such plots like violinplots, you need to understand your audience, as they may want the information in a simple way. Let's introduce hue parameter in our violinplot. So hue equal to sex and rerun this code. So now we have male in blue again and female in green. Rather than having a set of violinplots next to each other for male and female, we can use split parameter, and if we press shift tab, we have split equal to false by default. So we can use split equal to true. Split equal to true will draw half the violin for male and half the violin for female. This will make it easier to directly compare the distribution in nested categorical variable. So let's pass in split equal to true and let's rerun this thing. So here we have. So in this plot, the blue and green distributions are splitted in half of each violin for male and female. Now we can directly compare the distributions in the nested categorical variable such as sex in this case. Once again, the violin plot gives lots of information and comes at the cost of spending more time for understanding and presenting to others based on your audience. If you are dealing with more technical people, like data scientists, etc., they may have used violin plots, and this is a great choice to use while presenting the data. However, if you are dealing with more executive people like CEO or investors, you better use the box plot there because that is the more popular and commonly used for data interpretation. I suggest only use violin plots if you find something really interesting using this type of plot. Remember, understand your audience. The lecture is getting long. Let's split it here and we will start from the same point in the next lecture. See you in the next lecture. Good luck.